Alright guys, today's goal, the learner will be able to find real zeros of polynomial functions. So it says rewrite the expression as polynomial in standard form. So remember, standard form is highest degree to lowest degree, so what can we do here? So you'd get 2x squared plus 3x plus 1. So try to do that for the next one. Separate it, divide. So here you'd get x to the third minus 4x plus 1/2. Okay? That says factor the polynomial into linear factors. So linear factors have a degree of 1. So first thing we can do here is factor out the x. You get x squared minus 16. Well, what multiplies to 16 and adds to 0? Or negative 16, I should say. So there are all the linear factors. Here we do factor by grouping. So group the first two, change this to plus negative. Factor the second two. You can factor out the x squared. What are you left with? X plus 1. And then factor out a negative 4. What are you left with? X plus 1. So now you have x squared minus 4, because it was what's outside, times what's inside. Factor that one again. Factor the first one, you get x plus 2, x minus 2, and then you still have x plus 1. So there's that one. Last one, we'll start by factoring out a 6, and you get x squared minus 4. But that would factor into x plus 2, x minus 2. If you need help with this, we need to get caught up, so let me know. And that's what we got. So there you go. What you'll learn about: long division and the division algorithm, remainder and factor theorem, synthetic division, rational zeros, upper and lower bounds, and why these topics help identify and locate the real zeros of polynomial functions. Okay, let f of x and d of x be polynomials with degree of f greater than or equal to the degree of d. D of x cannot equal 0. Then there's unique polynomial q of x and r of x called the quotient and remainder, such that f of x equals d of x times q of x plus r of x. Whether r of x equals 0 or the degree of r is less than the degree of d, so it doesn't matter. The function f of x in the division algorithm is the dividend, and d of x is the divisor. If r of x equals 0, we say d of x divides evenly into f of x, meaning if there's no remainder. Okay? Use long division to find the quotient and the remainder. So that means this. You do. Watch what happens here. 2x to the fourth plus x to the third plus 0x squared plus 0x minus 3. What did I make sure I did? How is this different from this? I have the zeros included. When you're doing division, you need to include everything from the highest degree to lowest degree. So it goes 4, 3, 2, 1, 0. What are we dividing by? We're dividing by x squared plus x plus 1. So now just look at the very first term, x squared. You say, what do I have to multiply x squared to have it equal 2x to the fourth? And that would be 2x squared. See how I lined it up with the degree? It was a second degree. So you get 2x to the fourth plus 2x to the third plus 2x squared, and then you subtract. So what I did, 2x squared times x squared, 2x to the fourth. I did this. And then you distribute, line it up. Okay? So 2x to the fourth minus 2x to the fourth is 0. 1x to the third minus 2x to the third, negative 1x to the third. 0 minus 2x squared, negative 2x squared. So now you ask yourself, what do I have to multiply x by to have it equal negative x to the third? Negative x. So put the negative x out there, you get negative x to the third. Bring down that 0x. Minus x squared minus x. Subtract. Negative 1 minus 1, or negative 1 minus negative 1, 0. Negative 2 minus negative 1, negative 1. 0 minus negative x, x. So you go back up. What do you have to multiply x squared by to have it equal negative x squared? Negative 1. Once you get to the constant, whatever's left over is your remainder. Okay? So you get negative x squared. Bring down that negative 3. Minus x minus 1, subtract. Negative 1 minus negative 1 is 0. 1 minus negative 1 is 2x. Negative 3 minus negative 1, negative 2. So you get 2x squared minus x minus 1. So how would we write this? You have 2x squared minus x minus 1 plus 2x minus 2 over. What are we dividing by? X squared plus x plus 1. Okay? That's always the remainder. So did we get it right? See how they filled in with the zeros? See how we wrote it? Okay. It says if polynomial f of x is divided by x minus k, then the remainder is r equals f of k. Yep. Okay. So it says find the remainder when f of x equals 2x to the third. So if we look at that remainder theorem, r equals f of k, so this is what you do. You go x plus 3 equals 0, so x equals negative 3, so plug that in. So 2 times the quantity negative 3 squared is 18, plus 3 plus 12. I get 2133, so the remainder is 33. Let's see. It's possible I made some mental math. Let's see. Oh, there we go. A polynomial function f of x has a factor of x minus k if and only if f of k equals 0. Okay? So, synthetic division. So instead of long division, we use synthetic. Now here's the thing, same thing. What's the degree of this? The degree of this polynomial is 3. So what that means for synthetic is you should have a third degree column, a second, a first, and a constant. If not, we fill in with zeros. So now bring down the coefficients. 3, negative 2, 1, negative 5. So you do x minus 1 equals 0, so x equals 1, so that's what goes out here. You bring down the first number, you get 3. 1 times 3, 3. Negative 2 plus 3, 1. 1 times 1 is 1. 1 plus 1 is 2. Remember, these are just the degrees. Negative 3, so what does that mean you do? You have 3x squared plus x plus 2 minus 3. This is the remainder, so what were we dividing by? X minus 1. So let's see if we're right. There we go. Suppose f is a polynomial function of a degree greater than or equal to 1 in standard form with every coefficient an integer and the constant is not 0. If x equals p divided by q is a rational 0 of f, where p and q have no common integer factors than 1, then p is an integer factor of the coefficient and q is an integer factor, is the leading coefficient. So let's see. Upper bound, lower bound test. Let f be a polynomial function. Suppose f(x) is divided by x minus k using synthetic. If k is greater than 0, every number in the last 99 is non-negative, positive or 0, then k is the upper bound for the real zeros. If k is less than 0, the numbers in the last line are alternately non-negative and non-positive, then k is a lower bound. So let's find all the real zeros. Okay, so what it was saying is you take the factors of the last number, so all the factors of 8. So you have plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. Those are all the factors of 8, and then all the factors of 2 are plus minus 2, plus minus 1. So you divide them to get that. So 8 divided by 2 is 4, so you'd have all the possible zeros here. Positive or negative 4. 4 divided by 2, positive or negative 2. Positive or negative 1. Positive or negative 1/2. Are we missing anything here? Yep. 8 divided by 1, so you could have positive or negative 8. So there are all the possible zeros. So graph it, use your calculator to find the zeros. Doesn't mean there's all of those because there's a max of 4 of them, and we have 2, 4, 6, 8, 10 possibles, but use your calculator to find the zeros and let's see. So yep, here on the graph it looks like compare the x-intercepts of the graph, list the possibilities, and decide that 4 and negative 1/2 are the potential rational zeros. Doesn't mean there's not more, but there's all the rational. And then if you look, there's the negative 1/2. There's the positive 4. This one is a non-rational. Okay? So to get that real zero, you just have to calculate it. So if we have to find them all without using the graph piece, I want exact zeros. Didn't we just learn that one of them was, we have 2 of the rationals. We have x equals 4 and x equals negative 1/2. So start with synthetic division. So you do 4. Remember, make sure we have all of them. So 4th degree is 2, negative 7, negative 8, 14, 8. Bring down, you get 8, so 1, 4, negative 4, negative 16, 2, negative 2, you get 8, you get 0. So then didn't we also know that the next one is negative 1/2? Watch what I do here. Just copy down. You get rid of the 0 because it's a constant. Because there's no remainder. Okay? You can only do these when you have the rational zeros. Okay? So bring this down. You'd get negative 1, negative 4. So now what do we have left over here? Well, let's see. When we divided here, we went from a 4 degree to a 3 degree, and then 3 to 2. So you have 2x squared minus 4 equals 0. So add the 4, divide by 2, square root it, so you get x equals plus or minus the square root of 2. So let's see. There are all the real zeros. Okay? See you guys tomorrow.